So when I do a presentation in class or when we do this, then I gotta have to fix my camera a little bit. I always start with what are we gonna learn today? Why am I here? What's the objective or the target? Okay, it usually starts with SWBAT, which stands for students will be able to. So that by the end of this, you should be able to define, notate, and diagram common geometric definitions. That's our goal for the day. So I'm going to go to the next slide. Okay, so everything in geometry, the building blocks of geometry are all based on points, lines, and planes. So those are the first three definitions we go over because everything else can kind of be defined with points, lines, and planes. Okay, now I have dueling computers going on, so if you have a question or you want me to go back a slide, then put it in the chat and I can see all of you on my other screen. Okay, the first one is, what is a point? A point. The definition is a point is a specific location in space. It really has no size and it's usually represented by a dot. So for the diagram I have, okay, if you see something like this, I'm going to get my pen working. Dot, if you see a dot and a big A, that's what you're going to see, the picture, and that stands for point A. Okay, the notation. The notation, you don't have to put the dot. If I'm talking about that point A, I can, as long as I put it as a capital A. Notice it has to be a capital letter. You cannot use a lowercase letter or I will have no idea what you're talking about. So if you use one capital letter, I know that you're talking about a point. If you want to write it out, you could say point A. But we have to, in geometry, be very precise and very exact, and especially with our notation. I don't want to have to write out point A, and some of these are really long. I want to be able to use this just a capital letter, and when you use a capital letter, I know you're talking about a point, which is a specific location in space. Okay, so I'll wait a few minutes, make sure. Now, I did debate over this. I had another teacher who goes, oh, I'm going to type in the definitions on everybody's paper. And I go, yeah, but then nobody's going to remember it. I'm going to make her write it down. Because when I write things down, that helps me remember it. Okay? So, yes, I'm going to be the evil math teacher, and I'm going to get you to write down the definition yourself, because I want you to remember it, and I want you to write it down. Okay? So I'm about to go to the next slide, unless someone screams. And I'm looking over at my everyone over there, and I don't see anyone. The other thing is the definitions on that mix and match. You might have seen a definition like this, and hopefully you matched it up with point. Okay, here I go. I don't hear anyone screaming. Okay, the next definition is a line. Okay, a line is made up of points that extend indefinitely in opposite directions. So even though right now I only have point A and point B on my diagram, there's a points, right, indefinite number of points on this line. Okay, I just identify this location on the line, this location on the line. When you see a line, it's going to have two arrows. If it doesn't have two arrows, it's not a line. It's got to have two arrows on each, one on each side. Okay. Do you see this one thing down here? Let me see if I can move it around. It's a little scripted K. Let's see if it'll let me grab it a little bit. Or I grabbed it a little bit. Okay. You could, if you're going to talk about this line, you could use that little scripted lowercase letter. So when we're doing a notation, and I want to talk about this picture, I'm going to say line AB. It has to be capital letters. When you're talking about a line, you have to use 2 points. You cannot use 3 points. You cannot use 1 point. You have to have 2 points. If you don't want to have to write out line, which I never do, okay, then you have to come over here and you have to use this notation here with a capital A, B, and look what's on top of it. It's a line with, look, 2 arrows. If you don't have 2 arrows on, an arrow on each side, it's wrong. If you forget one of your arrows, it's wrong. Okay? Now this one, I just messed it up a little bit. Let me fix this. The only other way you could talk about that line, and I don't know why, see my little scripted K there? It's supposed to get moved up here. I could say line K. You don't see this very often, okay? Usually that you pick 2 points on that line, any 2 points you want, and you do A, B, and you put the little line symbol up above. But if you see a lowercase scripted letter, you could say line K. Okay? Now I'm going to move this up a little bit, even though it messes everything else up. Let's see. Okay, my example or my explanation, a straight path, it has to have a straight path with no thickness, and it extends forever. You do have to use a straight edge. A line is not ever going to look like this. That is not a line. Okay? Not going to work. It has to be a straight line. So if I did this, I now have this line here. This is not a line though, because I only have 1 arrow. I don't have 2 arrows. Okay? So we're going to be really exact. In these definitions, I'm going to try to show you things that it's not. Sometimes it's easier on a definition to tell you what it's not, and that kind of helps you understand what it is. I'm going to go to the next slide. Okay, a plane. Okay. A plane is made up of points that extend indefinitely to form a flat surface. So what I usually do in my class is I hold up a piece of paper and I go, okay, my piece of paper, that's the plane. Okay, and even though I only have just 1 piece of paper, it extends indefinitely this way, that way, all the way around, but it's this plane, it's this surface right here. Okay, that's why you can think of a plane. Everything that's on this plane right here, everything that's on this surface. Okay, when I want to show a picture of a plane, I show, notice it's not a rectangle. A rectangle looks like this because it's straight up and down. You have to make it sideways, like this. That lets me know that it's a plane. Okay? Then I have points. I have point A, point C, point B. Notice I have a big scripted R. It's a capital letter R. Okay, if I want to talk about this plane, I can call it plane ABC. I have to use 3 capital letters to talk about the plane. And I have to put the word plane right here. Okay? That tells me I'm talking about plane ABC. If I have another point on here, then I could say plane ADC. Plane BDC. As long as you pick 3 of the points on the plane to name it, you're good. Don't try to name a plane with only 2 points though, it won't work. The other way that you could notate a plane is if you said plane, you got to use the word, and you use a capital scripted R. That is not always on the plane. Only sometimes do you see that little naming convention for the plane. Okay, usually they just have a bunch of points and stuff on the plane. Okay, now notice this. That is not on the plane. So in other words, if I have my piece of paper here, okay, maybe that point's way out here. It's not on the plane. Okay. The other thing I can do is I can draw lines on the plane. Let's say I could draw a line here. Okay. If I want to show that this line is not on the plane though completely, look, watch what I can do. I go to here, and then, do you see that? That means that if I took a piece of paper here, and I took a pencil and I put it through the paper, so this line right here, part of it's on the plane and the other part is underneath it because it's dotted. Dotted means it's not on the plane. Only part of the line is on the plane. Okay, so you'll see that a little bit, and I'll show you that when we get to it. Okay, a plane is 2 dimensions, it's not 3. In other words, it only extends out on each side. It's not underneath, it's not up above, it's got to be on the plane. It's 2 dimensions, and it has to be represented by a parallelogram. It can't be just a regular rectangle. Okay, I'm going to go to the next slide. And I'm looking at the chat, and I'm looking at your faces to see if everybody's following me. A line segment. I wonder why I didn't do a line first. Hold on, I want to go look. Why I didn't do a line first. Maybe I missed the line. Where's the line? Did I already do the, yeah, I already did the line. Point, line, plane. Okay, a line segment. A line segment is a portion of a line that consists of 2 points and all the points between them. This is a line segment. Notice there are no arrows here, okay? However, I could make this a line, and when I talk about the line segment, I'm only talking about this portion right here. I'm not talking about the whole line. The notation for a line segment is 2 capital letters, and notice a horizontal mark right here. There's no arrows on either side. Has to be capital letters. Or we could write it out. Line segment AB. If you don't have that little guy on top, you have to write out line segment AB. Otherwise, there's something wrong. You're not identifying that line segment. I have no idea what you're talking about if you just go, okay, well, AB, blah, 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 blah. I'm going to go, I don't know what you're talking about. What is AB? You have to have that symbol there. Okay, it's 1 dimension, so it's going to be hopefully, it's not 3-dimensional. And it has to be straight. So this right here is not a line. It's got to be straight. All the way straight. That's a line. Okay, so that's what we got with a line segment. Okay, so let me show another example of that. Okay, I'm going to come over here. Well, actually, I could do it on here. I could call this D. Okay, I can talk about line segment DC. I could also talk about line segment CB. Okay, I cannot talk about AD because that's not a line. It's not on that straight line. It's like an angle. So you can't do that. Okay, array. Now, array is a part of a line, so it can be part of a line, consisting of an initial point. Sometimes they call this the end point. And all points of the line to one side. All to one side. Okay? And you're going to have an arrow on one end of it. Otherwise, I'm thinking you're talking about some line segment. But to be array, it's got to have at least one arrow. When you're going to do a notation, I'm going to say ray AB. The important part about rays is they have to start with the initial point or the end point, and the B tells me what direction the arrow is going in. So right here, I say a ray AB, that means it starts at A, that's its initial point or end point, and it goes in the direction of B. Okay, and then usually it's just, you have a little guy with one arrow here. Okay, I cannot, for this picture, I cannot say ray BA. That's not there. That would be saying there's this ray that starts at B, goes to A, but look, there's no arrow here. That would not work for that diagram. You have to be really careful with rays. You have to start with the initial point and then tell me what direction. Now, I get a lot of people that say, okay, well, let's say we did make this a line. Could I talk about this part right here? Could I say that's ray BA? And I could say yes. They go, well, then should I say BA and should I put the arrow going the other way? Well, usually we always keep the arrow going in the same direction. I have seen this before where they go in the other direction. But when it gets down to it, I'm going to look at the starting point, and the direction it's going in is going to be based on that letter. So you don't necessarily have to go and change the direction of the arrow. Okay, now I'm going to scoot this up in case you can't see it. And it is name the ray by starting with the initial point and name one point the ray goes through to indicate the direction. Okay, so that's how we're going to notate that. I'm talking about a ray. I'm not talking about the line segment AB. I'm not talking about the whole line AB. I'm talking about just the ray. So you can see where notation is kind of important in geometry. It's going to make a big difference so that we're all talking about the same thing. Okay, I'm going to go to the next slide. And again, I am recording this in case there's anybody that has a really hard time writing and maybe I'm going a little bit too fast for them. I am recording it. Okay, opposite rays. I'm just going to tell you on the first test, we always put this as a question, and this is the one everyone misses. So you might want to pay attention to this one. Okay, opposite rays are two rays that have the same initial point. So right away when you name two opposite rays, the first thing I go and I look at, and do they both start with the same point? And they extend in opposite directions, and they have to be directly opposite. One can't be this way and one can't be up this way. They have to be in directly opposite directions. So in this diagram right here, if I want to talk about the opposite rays here, I have to say I'm talking about this ray here that starts at B. Oops, this first one, let me erase that. The first one is ray BA. So the first one I'm talking about is B going towards A. So I'm talking about this right here on the first one. And an opposite ray would be BC. It starts at B and goes in this direction. Okay, I cannot say that ray CA, and there is a ray CA starting at C going to A, and ray AC are opposite rays. That's not true. Why? Do they have the same endpoint, the same start? No, they do not. I don't even go there. When we have this on a test, I immediately go, okay, is this the same letter? If it's not the same letter, then they've definitely got it wrong. Okay, so I know that's not going to work. Also, I'll have something like this. I'll have another line coming through here. Okay. And I'll have people that want to talk about the ray, and let's call this one point E, the ray ED, and the ray EA. ED and EA. And I'll tell them, nope, that's not right either. I looked, you both started with E, but one is in this direction and this one is not in the directly opposite direction. Won't work. So you want to be really careful with that. Okay, they do form a line, and they share only, okay, look at this, they only share the initial point. They can't share any other points. Guaranteed that is a test question. And when I mean test question, we're going to do a notation worksheet, and we're going to go over all these notations and give you a chance to try it out. I'm going to go over it with you, and if you can do that, you're going to be good. Okay? I'm going to go to the next slide. The next one is called collinear points. This means points that lie on the same line. Collinear, think of it as cohabitate. They all live on the line. Okay? So these 3 points are collinear. You could say B and C are collinear. A, B, and C are collinear. Any points on this line are collinear. If I do something like this, I put another line here. Okay, E is not collinear with A or C. It is collinear with B because it's on the same line with B. Okay, but they have to live. Think of collinear as cohabitate or live on the same line. Okay, now I don't know if I put an extra. I put it as separate because I'm going to talk about non-collinear points here. Non-collinear, and here's that little E, are points that do not lie on the same line. There's no notation for those. It's just that E, it doesn't live on the same line. It is not collinear with A, B, and C because they are not living or cohabitating on the same line. So that's called a non-collinear point. Okay. Okay, I'm going to go next slide. Coplanar. Again, coplanar. They have to cohabitate or live on the same plane. So you can have points like point C. You can have line segments like line segment AB. You can have rays like the ray BA. Notice I can't really do a ray A and going in that direction, but if I go in the other direction, I could say ray AB because I have to have 2 points for that ray. They all live on the same plane. Okay, if I come over here and it's not on my little parallelogram, my slanted rectangle, this is not on the same plane. Or if this guy was, I showed you that little dotted guy. Okay, that little dotted guy means I'm putting a hole through the paper, and that line is like actually putting a hole through the paper, and it's not, everything on the dotted part is not on the plane. Okay. And again, I don't know if I can't remember what I did on the notes, if I put coplanar and non-coplanar, if I just put coplanar. But the next slide says non-coplanar. And that means it is not on the same plane. C is not on the same plane. Okay? So you, and also remember a plane, it has to be a little parallelogram. This one, this B, well, I can't talk about that line because those points are not on the line. Now, if I had a line and I only gave you 1 point, could I talk about that line? Is it line E? No, it's not line E. To talk about a line, I have to have 2 points. Now, what about this part over here, Miss Webb? Because that's not really on the plane. It's not in that little parallelogram, but think about it. That parallelogram extends forever in all the different directions. And that line also, it's on the plane, but it will extend to infinity. So F is on the plane because it's on the line that's on the plane. Okay. Okay. Gonna go to the next slide. A midpoint. A midpoint is just a point halfway between two given points. Okay? So if I have this line segment AB, and I say here's M, and M is a midpoint, what are these little tick marks here? That's how I tell you that those two line segments are congruent. They have to be exactly the same. AM has to be the same as MB. Tick marks indicate equal lengths. Okay? So a midpoint is just a point halfway between two given points. Okay? And again, it has to be a midpoint. It's going to be on a line segment. It's going to be on a straight. It needs to be straight. There's not much to talk about on that one. But I like the little tick marks. You're going to see those a lot. Now, if I wanted to do a notation for the midpoint M, I could, when I do a point, I could say M, but I would have to tell you it's midpoint M. You know, there's no specific notation for midpoint M. It's just a point. So I would talk about the point M, and I would have to tell you it's a midpoint. Okay, bisector. Bisector means to cut it in half. Okay, a line segment or a line or a plane that divides a geometric figure into two congruent. What is this word here? What were you talking about? Congruent means same size, same shape. And I'm going to go over that at the end. But if you have anything that cuts something in half, you can say that's a bisector. So I have this line segment AB. And is this a line? No. Is it a line segment? No. It is a ray. Ray CM bisects line segment AB. Okay. And bisect just means I'm going to cut it in half. Okay, I cut it in half. And notice there's no notation. I have to tell you. Oh, ray CM bisects line segment AB. I don't have any shorthand to do that. I just wanted you to know whenever you see the word bisect, I'm saying cut it in half. And I'm going to go over this word because this is a really big deal in geometry. Congruent. Same size, same shape. That's my last slide when I talk about that. So, I'm going to go. Well, I'm looking over here because I see a few people and they're still writing, so that's why I'm worried. This one I totally skipped on the Google Meet for some reason in my other class. An angle. An angle, it's a figure formed by two rays that extend from a common point called the vertex. Okay, the vertex is B. Okay, so when I have an angle, I can talk about this angle here. I could say angle ABC. B has to be in the middle because that's the vertex. I cannot talk about angle AC or angle ACB. The vertex has to be in the middle. And it's got to have 3 letters, all capital. So I can say angle ABC. I can also, in this particular diagram, talk about angle B and just call it by the vertex. However, if I had something else coming out over here, if I just said angle B, I can't do that because I don't know which angle you're talking about. B happens to be the vertex of EBA, and it's also the vertex of ABC. So you have to be really careful when you try to call an angle only by its vertex. Better be the only angle with that vertex, otherwise it's confusing. Sometimes you'll see these little numbers here, and I can say that is angle 1. A lot of times they'll look like that. Okay, so an angle is usually named by a point on one ray, the point on the vertex and the point on the other ray. It can be named by the vertex if it is the only angle with the vertex. That's where you have to be careful. Okay? But always, and I get this on the first test, I'll have people that will call this angle ACB. No, it's not. I could say CBA, or I could say angle ABC, but that B better be the vertex. It's really important on that part. Okay? I'm looking around, I'm looking to see who's still writing. Okay. Okay, an angle bisector. Remember that term bisector? It means to cut it in half. An angle bisector is a line or a ray that divides the angle in half. And look, I put these little tick marks again. It's telling me that this angle right here is the same as this angle right here. It's the same size, same shape. Okay? And I say that ray BD is a bisector. So there's no like shorthand for telling me it's a bisector. Okay? Now I'm going to go a little bit over this congruent guy. When we say congruent, we use an equal sign with a little tilde on top. And that means same size, same shape. Okay? But if I come over here with my protractor and I tell you this is 45 degrees and this one is 45 degrees, I could do something. You'll see a little M of, this stands for measure of angle ABD, and you see where it says I could say equal. If I'm talking about measures, whenever I'm talking about if I use measurements, if I have numbers, I'm going to use the equal sign. But if I have this little symbol here, it says same size, same shape. I didn't tell you what the degrees were. I just told you they're exactly the same. If you're talking about two things that are same size and same shape, you use this little symbol here. If I've got some numbers in there, then I can use the equal sign. Okay, and if it asks for the measure of an angle, it wants to know the degrees. Otherwise, it's just talking about the angle. And I'm going to go over that at the very end too, because we always have that question, usually on the first two tests. Okay? Can everybody hear the saxophone in the background? I can. At least it's not the cat screaming, you know. We'll just have a little music going with us. Okay. Okay, parallel lines. You should have seen this in algebra. Two distinct. Notice they need to be on the same plane, living on the same plane, and they do not intersect. So line AB is parallel to CD. Okay, now notice I didn't draw the plane in for this one, so let's draw the plane in. Kind of a slanted rectangle. Okay, parallel lines, if you remember from algebra, they have the same slope, and planes could be parallel too. If I had two pieces of paper, one here and then one down here, I could say the two planes were parallel. Okay, but parallel means they never intersect. Okay, I'm going to go on. And oh, this is the symbol for parallel. It has to be kind of two slanted lines there. Parallel. I can say line AB is parallel to line CD. Okay, when we talk perpendicular, you should remember this from Algebra 1. That means the two lines, they have to have a 90-degree angle. When they intersect, they have to have a 90 degrees there. They form a right angle. You use the little square here to show, that's to let you know this is a right angle. It's 90 degrees. Okay, if I have two lines that look like this, are those perpendicular? No, they are not. Why? Because I didn't tell you that they were perpendicular. That's how I tell you they're perpendicular. Because what if it's not 90 degrees, it's 89 degrees? Okay, so you got to be really careful. So I always say, don't go by your eyes. Go by what I tell you. So I know those are perpendicular. That means they do not intersect, and I tell you that they form a right angle and they're 90 degrees. This is the symbol for perpendicular. Okay. Perpendicular lines have a slope that multiplied to -1. That's a freebie. Don't worry about it for now. We're in geometry. I just thought I'd throw that out there, see if anybody remembered that from Algebra 1. Okay, and you can have perpendicular planes as well. We don't see them that much, but you can have perpendicular planes. Okay? Okay, we're almost done. Here we go. I hate this one. This is called skew lines. We rarely see skew lines, but guess what? They love to put on your standardized tests. They love to ask you about skew lines. Although I'm not kidding. I cannot think of any of the things that we do that use skew lines, but I'm going to tell you what they are. They are two lines that do not intersect. So they do not intersect. And they are not parallel. They are not parallel. Okay, so in this diagram, these two lines do not intersect because you see the dots there. That means that pencil right there, when I'm doing the line, it went through the paper right here. Went through the paper and came out on the other side. So they're not actually touching because this is like a pencil going through the paper. So they do not intersect and they are not parallel. Okay? So that's what a skew line is, two lines that do not intersect, and those are definitely not parallel. Okay? A, B, and C, D do not line the same plane, and they do not intersect, and they're definitely not parallel. I'm just putting this one out there because in case you ever see skew lines, you know what they are for standardized tests. You don't see them very often. Okay, I don't really get into them that much, but I just wanted you to know if you kind of hear that word skew line, it means, wow, okay, they don't intersect and they're not parallel. You got to have both things true. So to get it so they're not parallel and they don't intersect, okay, one of them's probably going to have to be off the plane. Okay, last one, and this is the big deal. Okay, congruent, this is a big deal. In fact, we even put it on the first two tests usually. Okay, look at this. Two objects or shapes, but you want to think objects with the same size and the same shape are congruent. Congruent, that's how you say congruent. Two measurements can be equal. Okay, if I'm talking measurements, though, I can't say they're congruent. If I'm talking about objects, like I can say, let's say the best example is a circle. I can say those two circles are congruent. They're the same size and the same shape. If I wanted to use the equal sign, I'd probably have to tell you, oh, yeah, the diameter here is like, I don't know, 1/2 centimeter, and this one's 1/2 centimeter. So I could say the diameter of circle A here is equal to the diameter of circle B. But when I talk about the two circles, I'm going to say circle A is congruent to circle B. They're the same size and the same shape. Here is the notation for it. If I have two line segments, AB, let's draw it. I have AB and I have CD. They're both line segments. I can say those two are congruent. Did I tell you what their measurement was? No, there's no numbers in there. I'm just talking shapes. So to be congruent, you have to be the same size and the same shape. But if I talked about the length of AB, I said, okay, that's 1 inch. And the length of CD, I use the term equal. The length of AB and the length of CD are equal. Okay, when I'm talking angles, if I just have two angles here I could put one over here. I could say, oh, those two angles are congruent. But I didn't tell you what the measurement in degrees was. Now, if I say the measure of angle 1, I can say the measure of angle 1 is equal to the measure of angle 2, and that would be, I'm telling you the degrees. I could say this is 40 degrees, this is 40 degrees, and the measurements are the same. Okay, you can say two line segments are congruent, but you would say the length of two line segments are equal. So, first test question, I'm giving you the answer right now. What is the difference between congruent and equal? Congruent is I'm talking about objects or shapes that are the same size, same shape. When I'm talking about equal, I'm talking about measurements. I'm talking about the length. I'm not just talking about the shape. Okay? This is a really big deal in geometry. I am going to pause this.